All right, so today what we're talking about are volumes of pyramids. So volumes, we already talked about the volume of a prism, okay? And I want you guys to write this down on this first title slide, okay? The volume of a prism is the B times the height, okay? The volume is B, capital B, times the height, where capital B is the area of the base, right? Do you guys remember that? So like for this cube, right, we would take the area of this green shaded base and multiply it by, for example, the height, okay? Now, a pyramid is different. Why is a pyramid different? The shape in green is your pyramid, yeah? It's almost like a fraction of it, right? It's not the whole thing. It's actually a fraction. The only difference, the volume of a pyramid, write this down, is not half. What do you think it is? Closer. It's a third, okay? The volume of a pyramid is the exact same formula, but you multiply it by a third, okay? So it's a third, your base, capital B, times your height. Yeah. When that person comes back, okay? You just multiply the exact same formula of a prism by a third, okay? Now, Mr. Grusky and I realized that the SAT does give you a reference sheet that has formulas on it, okay? So we are going to be giving you that reference sheet on the next exam, okay? It's going to have... So, let's go ahead and talk about what a regular pyramid is. A regular pyramid has one base that is a regular polygon, okay? So as long as your base is a regular polygon, all the lateral edges are congruent. All the lateral faces are congruent isosceles triangles. And the altitude meets the base at its center, okay? And this is for just a regular pyramid, okay? How I like to identify a regular pyramid is it's not slanted at all. It's all symmetrical. Everything is congruent. All the lengths are congruent, okay? The slants heights are all congruent. The height is one fixed value and it lies straight in the center. The altitude meets the base in its center. Now, there are pyramids that are not regular, and they also follow the same formula, okay? These properties only apply to regular pyramids. Okay. So, as we talked about, the volume of a pyramid is just 1/3 the area of your base times the height. And in the figure, it lists everything out, where capital B is the area of that square base, and H is the value of your height. Okay? So for us, let's just say we were given this problem, right? And we were told maybe like this is your length and this is your width, okay? Let's maybe rewrite our formula with length and width instead. So how could I rewrite the volume of a pyramid, of this pyramid, with length and width, not with capital B? Very good. It's just length times width times your height, okay? And it's length times width because in order to find the area of any rectangle or square, you just multiply the length and the width together. Questions? Okay, let's do an example. A regular square pyramid has base edge 6 centimeters and a height 12 centimeters. Find its volume and give the exact answer, okay? So there's some very, very specific stuff that's given in this problem. Okay. Okay. A regular square pyramid. What does that mean? Christian? All the what? All the edges are the same. Very good. What else does that mean? What shape is my base? A square, okay? So let's just draw a square. What does it mean to be a pyramid? They go up and they meet at what? At one point. So draw that point at the top of your figure and just draw some lines connecting to each of the vertexes of your square. Okay? Now, since this is a square, these lengths all have to be the same. Do you guys agree? So all we need to do is find the area of this base and multiply it by the height. So it says it has a base edge of 6 centimeters. What does that mean? What does that mean? Xavier? Very good. They're all going to be 6 centimeters. Why are all of these 6 centimeters, guys? It's a regular square, okay? So they all have to be 6 centimeters. And what else did it tell me? It gave me one other piece of information. Zoe? The height is 12. So this dotted line going from the top to the bottom is 12 centimeters, okay? All right, and we just need to find its volume, okay? So to find its volume of this pyramid is equal to what? What's our new formula? 1/3 base, the area of your base times the height. Now, our base, you guys agreed, was what shape? A square. So how do you find the area of a square? Multiply it by, like 6 times 6, right? The length times the width. So we're going to get volume equals 1/3, 6 times 6, and then multiply it by the height. What was the height? 12. So our volume is 1/3, 6 times 6 times 12. Uh, 144. What units is this in? Centimeters cubed, okay? Now, remember, if you put centimeters for all these, you're going to see that you had 3 units of centimeters, and that's how you could calculate centimeters cubed if you were confused, okay? We multiplied 6 centimeters by 6 centimeters and then by 12 centimeters, and then divided it by 3. No. Okay. Find the volume of the triangular pyramid, okay? How is this pyramid different than the one that we just saw? It's not a square pyramid. So in a triangular pyramid, what shape is my base? It's a triangle, okay? So find the base of this pyramid and highlight it, okay? The base right here, do you see how it's this little guy down here? So when we're finding the area of the base, we're finding the area of this triangle, okay? So remember, volume equals, what's our formula? 1/3 capital B times height. Yeah, I saw that. All right, so in this one, what's the area of my base going to be? Very good, Jaden. It's going to be 4 times 3 divided by 2. Because the area of a triangle we'll put it in parentheses, capital B, is 1/2 base times height, which is 1/2. Your base is 4 units, and your height is 3 units. So if we multiply that out, we should get that the area of our base is how many units? 6 feet squared. So we're going to take that value and plug it into the formula for volume. So our volume is equal to 1/3. Your base, which you just got, was 6 feet squared. What's the missing piece that we don't have? The height. But are we given the height? We sure are. What is it? It's 7. So you just multiply by 7 feet. And we're going to get volume equals We should get 14 feet cubed. Can someone confirm they got the same thing? Okay. Yeah.
Did you get marked off or do you put the units in the parentheses?
No. Okay, as long as you have it in the final answer, I'm happy. All right. Did everyone hear Christina's question? Will we get marked off if we don't have the feet squared in when we're plugging in? No, the answer is no, okay? I like to write it because it reminds me, okay, feet squared times feet will give me feet to the third power, okay? But as long as you have it in your final answer, I'm a happy camper, all right? Okay. Let's do the same problem, but we don't know what the height is. We're given the volume, we're given the base, we're given the height of the base, but we don't know what the height of the pyramid is, okay? So let's start with the same formula. Volume equals 1/3 capital B times the height. And what's the area of my base now? Christian? It's 9. It's 6 times 3 times a half. So the area of my base, which I'll highlight in red, is this guy right here, which is going to be 3 times 6 times a half. So it's going to be 1/2, 6 times 3, which will give me 9. So we have 9 meters squared as our base. Our volume was 24, and we're looking for the height. So let's plug everything in. We know that 24 meters cubed should be equal to 1/3 times 9 meters squared times your height, which we don't know. Yep.
Why is it meters instead of feet?
Just because, do you see how the lengths were given in meters for this one?
Oh, I'm still not looking at it.
Yeah, I'm just using that fact, okay? All right, so then from here, how could we solve for h, guys? What would be our steps? Savannah?
First, you would multiply 1/3 times 9, which is 3. And then
Oh, okay.
you divide 3 meters squared divided by, well, 24 meters cubed over 3 meters squared, and that would give you 8 meters.
Good, so you divided both sides by 3 meters squared?
Yeah.
Excellent, because we want to get h by itself. So remember, when you're dividing meters cubed by meters squared, what's going to be left over? Just 1 meter, right? And 24 divided by 3 gives me 8 meters equals my height. This is a good check for you guys to make sure that you're in the right units, right? Because if you did meters cubed divided by meters cubed, then you'd be like, oh, I messed something up because my units don't match, okay? You want to be left over with 1 meters because your height is in terms of meters. So our height here is just 8 meters. We're almost done, peeps. Bear with me. I'll be done in the next 6 minutes. I promise. Okay. The volume of similar solids. Do you guys remember when we talked about similar solids and we compared their areas? Maybe you forgot, okay? Well, so when we compared area, right? I think we already talked about this, but I could be wrong, okay? The area, okay, was proportional by the scale factor squared. Do you guys remember that? And then volume would be proportional by the scale factor cubed, okay? So if we have pyramid A and pyramid B and we're given that they're similar, okay, you find your scale factor by taking 2 of the same length. For example, the height here. We know the height of this one and the height of this one, and you create a fraction with them. So we're going to say our K is going to be pyramid A over pyramid B, and the height from each of them would be 8 over 6. Okay? Let's go ahead and simplify that scale factor. What does 8 over 6 simplify to? Dylan?
3 over 4.
Close. 4 over 3. Okay? So this is going to simplify to 4 over 3, right? And then all we do is we just cube it. So we're going to say K cubed is going to be 4 cubed over 3 cubed, which is 64 over 27. So this is our scale factor for the volume. We have to cube it in order to figure out it's the scale factor for the volume. So we're like, okay, K cubed should be proportional to the volume of A over the volume of B. And we don't know the volume of B, okay? That's what we're trying to figure out. So we're going to say 64 over 27 is equal to the volume of pyramid A, which is 96 meters cubed, over the volume of B. You would then cross multiply and divide. You would get 64 times the volume of B equals 27 times 96 meters cubed. You would divide both sides by 64. Divide both sides by 64. You're going to get the volume of B is 27 times 96 and then divided by 64. And you would get 40.5 meters cubed. Jaden. Yes. Yep.
And then 8 and 6.
Yep. Okay, so are you okay with the fact that to find my scale factor, right, which is K, I need to take a length from pyramid A and put it over pyramid B, or vice versa?
Or did you just divide it?
I just divided both the numerator and the denominator by 2. Okay, so that's how I got 4 over 3. Does that make sense? Now, you could also cube 8 and cube 6 and get like 64 times 8, something in the numerator, something larger in the denominator. I simplified because it becomes easier numbers to deal with, okay? But it's not going to change your answer. Good questions. Any other questions on this one? All right. And then lastly, let's do another composite solid problem, okay? So this one is going to be a prism and a pyramid. Let's see if you guys can figure it out. Go. All right. What 2 figures are here? What 2 shapes do we have? Xavier? Excelente. A cube and a pyramid. And it is more specifically a square pyramid. Absolutely right, okay? So we have to find the volume of each and then do what with their volumes? Add them together. Did anyone find the volume of the cube? Savannah?
Isn't 216 meters cubed?
It is. How'd you get that?
I multiplied base times width times height, length times width times height.
Yep. Which is length times width times height.
Yeah.
And you got 6 times 6 times 6, which gave you 216 meters cubed. Excellent. Savannah is correct. That is the base or the volume of the cube. Okay? What about the volume of the pyramid? Javier?
It's 72 meters squared.
72 meters squared. How'd you get that?
So I did 1/3 times BH, which because it's a square pyramid, it's the B is 6 times 6.
Very good. So it's going to be 1/3, 6 times 6 for the base. And then what was the height?
6.
6 as well. Okay? And then you should have gotten 72 meters cubed. Which one do I pick? Neither. What do I do with them, Christina? You add them together. So we're going to do 72 meters cubed plus 216 meters cubed. And you should get 288 meters cubed as the volume of the whole thing. Yes?
I thought when you tried to find the base, it was 1/2 times base times height.
That's if, okay, I love that question. Guys, can someone answer that for me? When do we use the formula 1/2 base times height? No.
When you find the area of the base.
An area of what kind of base, though? Stephanie? A triangle. Is this base a triangle?
Oh,
No, the base is what? A square, okay? A rectangle or a square. That's where we use length times width. Cool beans? Yes, turn these in.